Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. Today we will continue making this awesome debugger, and if you'd like to follow along, please don't hesitate and welcome. If you have any questions, you can post them on Twitter or YouTube, and I'll be there to answer. With that said, let's start. So, if we remember, the last thing we did on the last stream was that we were trying to disassemble another instruction, and we did that. It was a movie instruction. So we can go and see what we did. So this is our stream test, and the last instruction we added was this move REX RDX, and yeah, well, that was the whole thing of the story the last stream. So today we can, now that we print it out, we can try to like define a little bit more thoroughly what the operand size override prefix and address size override prefix does. If you remember, these instructions, well, they don't do anything right now, which is something that we could do, of course, like adding the operand size prefix, stuff like that. But before doing that, I would like to go back into the ISO, and if you see here, well, the one that we disassembled, it was this one, rex.w that lost 89.r, stuff like that. So we disassembled this instruction, which is not valid on compatibility legacy mode. So first of all, I would like to disassemble the same instruction without rex, just to see that, we can do that as well. And then disassemble the other instruction without rex, but in 16-bit mode, and going one by one, so I can see, so that we have, so the disassembler can classify, can distinguish between same mem opcodes, and the ones that have rex, and the ones that don't, the ones that need an effective operand size attribute of blah, so all the stuff's super important right now, and we have to try to find that thing. So we're gonna go to rec, same opcode, different instruction, so that's the main point now. So let's go and do that. Let's go and do the 32 one. It's just the same idea, now with different opcodes, so with different operands, sorry. Oh, I'm sorry. It's 5 in the morning, and yeah. What can you do? So if you see here, where can I put the string here? So this doesn't this won't have the same 0x. I don't know, here it can be the same, I guess. It's not super relevant. We just care about the same of pi in this case, you know. So we can have that, and then compile. Now if you think about it, it would be nice if at compile time we know that, hey, this is not disassemble compatible. But it's like kind of saying like, well, you know, first disassemble it in compile time, and then decide whether or not you can do the disassembly at all. Which, yeah, I mean, it's just me at 5M thinking about possibilities. Okay, so let's do that. And you know, the first thing that I can see here is that if I run this, we're gonna get a valid instruction, of course, because, well, if you see here, we're not gonna have an react, so everything is gonna be 6432. But if we go to the entry, then blah, you know, we get a valid move instruction, and the reason is because, which if I show you, it's telling us that we have an rex present, which we don't have, of course, and well, pretty much the other things the same, I guess. Yeah. Oh yeah. So we got the, let's say we got the invalid entry, yeah. We got an invalid entry, or let's say we haven't have that a better class, well, like, yeah, we haven't added that entry, you know, as well, if you happen to make sense. Yeah, I mean, we have to add the entry first of all, but also, well, we have to find out a better way to classify this stuff, because the main by is not gonna do it, you know. We cannot just get as input the main by and say, hey, you know, we're gonna find your opcode just as it is, which we could, you know. I mean, there's not pretty much any difference between. I mean, it's still a move instruction. We know. I mean, we're not looking at a different instruction. Sometimes it is, but it changes only with the mode of operand, which is important. So we have 89, 89, 89, and then you know, So I think now that I think about, well, if that's the case, well, there's some repetitive stuff here. We have a map set, depending on variant size attribute and stuff like that. We have AX, EAX. So we can do the same stuff, Now think about it, well, we can just change this. I thought it was like, I mean, adding an entry with that thing, it would be pretty nice and stuff, But if the only case scenario that's gonna happen when we change this, when we have the special case for the RX prefix, it's just cause we notify that it happened to have it. We pretty much can do that, because the well, since we, at least, well, since we haven't done anything yet with changing of mode, it's gonna work, The only thing that we have to think about is just like that the division of if it's compatible on 64-bit mode or not, which probably, I mean, it's something that we should start to do that now, because if not, everything's gonna go bananas. So it's not something like super crazy and stuff, It's just that for example, most of the ones that are not compatible are with REX, so the REX can be checked as it. Not encodable, sorry. This is an NC, which is not compatible. Or I thought it was, because now it doesn't have a... It has a wonder. That was a weird instruction. Where is it? REX, 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 REX. Dude, I lost it. It was... where is it? That was super weird. Where's the NC one? Any. There's no anyone with NC? Dude, that's kind of weird. Well, so yeah, I mean, pretty much, well, now that I see the NC, it's kind of super weird. I just, in the moment before, I was looking at compare legacy mode flag that tells me NC, which I don't know what it is, but now it disappeared at all. It's this one, isn't it? Dude, man, doing this thing at 5 AM is just super crazy. I thought this was an... Oh my god, I can't believe it. Yeah, it was this instruction, isn't it? Yeah, it was the map set or thing. Where's the map set? No, map sets. What are the map sets? Yeah, these are the map sets. But and it was this I0. Whatever. So yeah, it's not encodable because it has the REX. So it's pretty much because of the REX, isn't it? So we have to just do care about that, like, hey, REX stuff, we're not gonna print that out if you have an REX, we're gonna think about ERX as another instruction, you know. In fact, well, if you remember, we can do that first. We can do both things. Well, first let me do the disassembly of this instruction. Then I'm gonna make the switch for the 89 stuff. Yeah. So we added that. You know, it's the same thing. 89 the 0. And first of all, I'm just gonna say that fetch register operand. It was fetch register. It's gonna have the RxPresent be passed along. Now there's a reason why not to do that. Well, you know, I'm gonna keep it this way for now, because it's good to have simple types passed as parameters. So, well, that's the only change there. You know, RxPresent, it's gonna be the thing. Compile, and then here we have to pass RxPresent as well. we do that? Oh, I see the problem. It was the same name, so my bad. Now the only thing I don't know if this is gonna do the thing that I'm expecting it to do, because it's gonna make first assignment and then, well, first gonna do the parentheses. So the parentheses, whatever is inside parentheses, is gonna be first done. So the assignment is gonna first be done. Now I want the array expression to be returned first and then to be copied. So I want that. Then the copy, and then the assignment, and then the checking of the statement. Which, yeah, so this is better like this. Now the array expression is something that we can do add as a operand instruction thing. And I don't know if it would be too hidden for that particular case, but you know, that's gonna work. If we see that need, if I feel in the guts to make the change, well, probably. But if we do this and we change this so that, if you remember, in the entry, so the entry is not gonna have that comparison anymore. You know, what is it? Tables. We're gonna get to the entry here. We're not gonna have that. We're gonna get an arrow here where it's okay. Now rectimal RAM, true, and we have an effective. So pretty much this entry works as a series of instructions, because if you think about it, we can just encode 16, 32, or, well, I don't remember, it was, yeah, 16, 32, and 64, depending on the operand size attribute. So yeah, I mean, that's the whole thing, you know, we don't need another entry there, so that's good. We're not gonna have a huge thing there, and yeah, so if we do it that way, I just took it out, and we can see what happens. Yeah. So the first instruction is the 32 one. We don't have an array expression, so we're gonna say, well, you know, tell me that the effective operand size is gonna be 32 and 64. So we get a mnemonic, which is the move, the same thing, and the multi-RAM, recti-multi-RAM is going to be the same. You know, we have a multi-RAM, we have a recti-multi-RAM, and that's it. Recti-multi-RAM. it's valid, there you go, begin operand instruction. We're gonna fetch the memory operand, just a register. You get the buffer with EAX, that's correct. We're gonna fetch the register operand, which is EDX, that's correct. And we're gonna fetch the immediate operand, which is nothing. So that's pretty much the instruction, isn't it? And if we go to the next one, it should have an REX where we are. On the 48, that's correct. So there you go. We have a 6464 thing, REX present. It's valid mnemonic entry. We have a move, there you go. The main buffer should be REX, RDX, that's correct. And null, there you go. And then the other stuff. REX are the X, bound EAX, EVX is X times 2. The other stuff can be matched. Add away, fadd st0, st1, fcom st1, st0, fld 0004, vm resume, pline xm0, xm1, 00, 083, shield 0003, 8 add EAX 0000. So yeah, that's pretty much the same thing. So now that we print that, we can say, well, have the same instruction, we can print any operand sizes, so now we can print we can print pretty much the 3 instructions as well, you know. If we added an effective operand size overrider, because then it would be the case. So I think what I like to do is just to pass it here. I think I like that. Now, yeah, it was the trade-off between having all these asserts But yeah, that's okay. AliExpress. Well, we're gonna assert this because some of the times it's not gonna be done. So yeah, cannot assert that. So that's okay. This has some. There we go. Of which can see apply. See entry. Mm. We have open offset. So yeah, I don't know. We can. I don't know why we were doing this, but doesn't matter. For now, this is for adding stuff. So it's just like a counter. So we have that. And we have the same as well. Okay. So yeah, that's pretty much it. So now I would like to add we can add the other instruction. We can have the same instruction just with a 16-bit thing. Now for 16-bit and stuff, we have to have an operand size override prefix to, yeah. So first of all, well, before doing that, I would like to start making the division between which instructions are possible in 64-bit mode and which are not. So for example, if I say that we are in 64-bit mode, and that's gonna pretty much define the whole disassembly process. So that's something good to do. Now here's where it comes an interesting question. It's like, well, what happens if we don't find something? What happens if we have an instruction that is just bananas, that it doesn't have any kind of meaning on the mode that we are working with? So I think is that, well, if we don't have, if we go and find out that we don't have any meaning of it because of the not encodable thing, so probably we can just skip it until we get to a byte that we just understand. That's one. Of course, that's going to be totally bogus and it's not going to be correct. Sometimes it is. Sometimes, for example, let's say we have a well, this is an instruction. It's about instruction, so that's not the case. Yeah. Well, I don't know. Check if we can have more than one. Okay. Mandatory prefix present. So in fact, I can say this. Which, I mean, it will be a little bit hidden, but I think it's good because specifically for this case, it's just that it wouldn't get it, you know. So I would say we can get rid of this, isn't it? Yeah. For now, I'm gonna keep it this way, even though they're not the same, you know, because one is virtualized and the other is real. But So we can do this, and say, well, we're gonna default to this. I was just gonna say, well, and we can pretty much erase all these stuff. We don't need it anymore. So yeah. And that's pretty much the thing. Initialize up table, blah 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 blah. so that, well, right now we don't care too much, but you know, just to start to looking at the thing, because here we're gonna make file IO or stuff, something like that. So this is gonna go there. So I'm just gonna say for now this, but that's it. Array expression, disassemble state, cby. In fact, probably init table. Well, this can be pretty much the same, I guess. Yeah, I was trying just to make like kind of assertion there, so it will be pretty much easier for us to check that we have a valid entry, you know. Does get entry index returns a valid. Well, in this case, it's not gonna return anything, isn't it? Which we can do is something like this. Well, we're breaking, isn't it? Okay, so we are not adding the whole stuff, but that's okay because you can just say so. Now this is going to take the possibility to have 65536 entries per table, per group, sorry, which probably we wanna keep the 4 billion thing because, yeah. And here I'm just gonna say that, well, and we can just say, well, the same stuff there. If not, we're gonna try to do this stuff differently. So for the get mnemonic, we're gonna do pretty much the same stuff and say that the table ID something like, well, it can stay the same, I guess, because the RX prefix, we can get a table itself, so we have to make sure that whenever we got 64-bit mode, we can just do this if 64-bit mode so we can just say it was more simple that way. Of course, it's not something that we want to do, so I can say if so that's okay. Now I remember we have it here, EagleFly internal. So yeah, that's pretty much it. So REX prefix is already done. Checking. So that we only use them for that particular case. Now there's some instructions that are not encodable, so probably want to say that here. We don't add it to the table. Well, the only problem, well, the only case scenario here is that since we're on 64-bit mode, we'll this has some. We're gonna have this instruction is only 64-bit. This instruction is only 32-bit. This instruction is valid 6432. This instruction is only 32. This instruction Well, in fact, let's go and check it. Let's go and check it. So the mu do you see this 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 outbounds the move instruction. It has way much a lot more, yeah. The jump instruction has a lot more encodings, which is kind of funny. This is the interrupt procedure, which is some stuff there. Look at that. We're gonna see that later. I have to. There are a lot. Of course, the thing I was in the where I am. Convert to PS. Let's see. Oh my god. This is the call. It has a wide description there. PCHI is your high bit starting with specified bit position. Bit test and set. Big was logical and packets. Yeah, okay. Well, I'm gonna go just straight. I was like, wow, where is it? I'm just gonna go and find it. No. Here we go. So, if I am correct, well, we have this one. 8 immediate, add blah 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 immediate, which is valid on both. Okay, so we have that valid. So we have this add, (6432). That's correct. This is only 32. If add, and we have here another add, isn't it? We have the other add, which has an EAX, so it's a 32-bit and a memory operon. So it has to be rather, you know, it has to be rather this one, isn't it? Because this is a memory operand 32 and a 32 register operand, which is the 03, and then we have the 05. This is R means that we use both the rec and the RM. That's correct. That's the thing we use. So it's this one. So it's both valid on both. Okay. So I can say this is valid on both. Now we have FF. Well, FF instruction. Yeah, it's 0305 displacement. So yeah. Okay. So yeah, let me find the FF thing. Are you serious? Are you serious? Where is the? Oh my god. Where's the encoding for the FF? Does the general purpose? Yeah, it should. Yeah? That's totally bogus. Here we go. This is the FF as we have the programming with the machine sex or embodied status flex. But first, guidance for writing the file point exception. Okay, okay, right now, but then here you go. There you go. It's like where? Okay, so we have the FF and we have, if I remember, ST0 STI. So we have a D8 C0 1. That means it's valid on both. In fact, well, all the FATs are valid on everything. So and 64 incompatibility mode, that's kind of nice. So we can say that it's valid on both. We have C0, C plus I. That's the case because you remember, well, I don't have it here. It was somewhere across here. But yeah, we have this one. It's the only one that has the D8. We have this one as well, but this uses the M32 from memory, which is not the case for us. We are loading from using the ST0 STI thing. Oh, let me see. Rec name stable. So we have, yeah, just one D8. Which is D8 C1. And this is D8 C0 plus I C1. Good. Then that's gonna be ST0 STI valid. Okay, good. That's good. Valid 64 32, only 32. Valid 64 32. The FUCOM. Let's try to find the FUCOM. It should be through here. FCLX, FCMove, FCOM, FCOMI, FCosine, F decrement stack top pointer, F division, FICOM, FIOP, increment, fist, we have an F load, isn't it? Is this, or is not this one? Is this one? We have this one, and we have I don't remember which one. I think it was D9. We have FLD, and we have, it has to be DD, because it has to be I don't remember. D5 is not a floating point instruction. DD it is, and DD it is. So yeah, it's this one, isn't it? Yeah, because this is the loading thing. So it's DD05. Which is the extended opcode thing. Now this is a 64 floating point onto the FPU register stack. That's a little bit weird, isn't it? Well, it's the memory, it's a floating point 64. That means we're loading a double precision thing onto the FPU register stack. So one thing about displacements right now are fade 2. but they should be 64 because on 64-bit mode have to be 64 bits wide. So that's something that we also want to do. But this, so this shouldn't be this. It should be with other zeros up there. So this is gonna be valid on both as well. And I'm gonna put it either. Where can I put it? I can put it here, or I can put it okay. So yeah, so if it's a 64-bit memory operand, that means that I mean, it's okay because we are just looking at the register, but the register is also the register, the address. But even though, you know, FLD should have its thing done there, which is okay. It doesn't matter. Well, it's okay. We're gonna do that later, but this is a good instruction because we didn't know that. And we have a DB5, which is an M80 on the blah blah blah. Okay. So this, I'm gonna push M64 FP until blah, blah, blah. Now Fucom. Here you go, we have Fucom. And I believe, well, it's DD. It has to be DD. And we are comparing ST0, STI, isn't it? Now we have it the other way around, STI, ST0. So we have well, hold on me. We have DD E1, ST0, ST1, DD E1. So this is valid. VM resume. Now the order, I don't know if the order matters here, because we have this one and it's valid. We have ST0 with STI. These are the results, C3, C2, and C0. If it's greater than, if it's less than, it's equal. Normally, we found out that it was the case. It was this one. No, it was something that we just did, isn't it? It's like, well, we tried to find out something and we just made the instructions. So it has to be ST0, ST1. So the indexes probably are incorrect. So probably, I mean, it's not super huge deal there because it's just an order comparison, but I'm gonna put it to do as well. So for example, if I say, just because, well, we can do it here. Let's do it. Alright. We're gonna have like a processor register cannot be first open. Are you serious? Are you serious? Processor register cannot be first open. That's a little bit weird. Sorry. So you have to check that. It doesn't matter right now. I was just trying to do it. So if you see, yeah, it's because when we saw the FUCOM here, we saw that the order of them was that. So I was like, well, that's the case. So this is, it has to be DD. Here we go. And we have this one, ST1, ST0. That's why we did it that way. Oh, I see. It has to be FUCOM STI. This is My bad, my bad. Yeah, it's implicit. So I printed both, but oh, this has to be like this. So yeah, it was. I mean, it's not correctly done in the assembly because this zero is always implicit. So this assembly looked like this, yeah. And in fact, well, even though we can just say Fucam and it would be the same. So if we go to the dumping, have we have Fucam st1. Yeah, pretty much it. So yeah, that's nice. And it's valid on both. Okay, that's correct. So we have a Fucam that's valid. All of them are valid on 64-bit compatibility. What other instruction we have done? The VM resume. Let's try to find the VM resume. This is the opcode OF01 C3. Yeah, we have OF01 C3, which is this one. And as such, the VM resume. Well, let me see. This is instructions to reference. We have VM resume. It doesn't tell us if it's 64-bit mode or 32-bit mode, and the reason is that it's not that. You know, I have to read a little bit more about virtual machine instructions because those instructions, I mean, if I put VM resume here, it's just like saying, well, you know what, test and VM resume. It was possible. That means that 64-bit mode doesn't have any problem. Of course, it's not gonna do anything. Probably it's gonna just crash because we haven't even launched it. So probably that's the problem. Okay, so we know. And it cannot be used after the move to SS. Alright. So yeah, I mean this being resistant thing, we have to check a little bit more. But we have to have a series of the information. It doesn't depend on 64 or 32 or anything. It respects the BMX operations and the way that they work. So we have to check that later. So BMX is gonna be defaulting now. I mean, it's possible to encode it on 64-bit mode. We saw it. So I'm gonna just say that we have a valid 32 and 64. P align. This is SIMD. So let's see fine. P align. Well, it's P align R, I guess. Yeah. We have P align, and we have this one 66 OF 38 OF. Mod rec mode rec area immediate. This is the thing. 64-32-bit mode support. It's valid in okay, it's valid on both, so that's nice. It's valid on 32-bit mode and 64-bit mode. Now, just think about this for a moment. The reason that they put it, well, it's the same, but if you remember on the other ones that are not SIMD, they had two columns. You know, we had 64-bit mode and compatibility mode, or yeah, it was compatibility mode. Which I mean, what I think it is that, I mean, you need the feature flag to be on. You know, sometimes we on the CPU ID, of course, it's not like, oh yeah, you're gonna have that thing, because since it's an extension thing, it's not like dependency on 64-32. It works for both because you can work with them on compatibility mode. The only problem is that you have to have the feature flag. That's the only thing. That's mostly how SIMD instructions work, and AVX and stuff. So, for example, yeah, so AVX, no, sorry, no, SVX. Well, the VM resume is just the same idea. We have to find out the CPU ID feature flag for SVX, and we'll have that. You know, we can have system virtualization extensions. It's just the same idea. Probably it's not in there, but yeah, it was implicit. So it's the same idea here with Packline. So with Packline thing, it's the same thing. But yeah, I can just copy this. Well, valid 64-bit CPU ID. It's an SSSE3. And this has a CPU ID SVX. And we are just missing the shift left double. This is P-align R, so let me change that to R. And here, where is the P-align? This is P-align R, P-align. This can be the same, I guess. P-align R. And the shift left double. C108. Door precision shift left. Okay. we have OF A4 immediate, I believe. We have OF A4 O5 displacement immediate. Yeah, OF A4 O5 displacement immediate. So we have this one, or it can be this one. Yeah, because this is 16, we have 32 one. Yeah, because, well, we need here another operand, isn't it? Because we have 32 immediate, so we are missing. Oh, it's because it has O5, but it has to be EAX, isn't it? Because it's O5. So we have O5, that means we are using EAX. For the thing. And an immediate 8 that should be sign extended. So we got that wrong, so let's fix that as well. But this is well, what is it? We are looking at this one, which is valid on both, on comparability, legacy mode. Okay. Okay. So this is instruction. We have another one here, which is move EAX, EVX, which is valid on both as well. Which is this one. So yeah, so let's compare that and let's see why is the reason that we don't have the shield complete. So this is not correct. We found a bug that's correct. That's good. So let's go and see what's going on there. We get an exception. And we have C byte is 89. Oh, okay. So this is, thank you, asserter, thank you. Assert. Where is the sir. Where do we have it? Fetch register or get mnemonic. Yeah, here. So this is or. So we have RAX, the same stuff, but the sheaf, it's missing some data there, yeah. So let's go to the sheaf instruction with let's say we have a sheaf. How do we have it there? Here you go. So the sheaf is this one, I believe. Yeah. So it's this one, and we can just say A4. No. Well, OF. Yeah. Well, we already have it, isn't it? Okay, good. So we just do that. We get there. We get there. We get there. We get there. And I believe it's this one. I don't remember. We get, yeah, this is a shift left double. It's correct. It's valid. There you go. We have a mod RAM. Yeah, we have a rect to mod RAM. Yeah, we have a. Oh, it's because the register operand size is invalid. That's the problem. There you go. So we have to change that as well. And go to init up table with the shield, and we gotta say register operand size is gonna be, I don't remember, it was EAX. Let me see, because if I think it's more like effective, but we can check it. We have OFA4, AFA4, we have 16, 32, or 64. So yeah, it has to be effective. Most of the time it's gonna be effective if you think about it. It's just special cases where we don't have the effective cases. And if we do, we should have the effective and the other case special, you know, which is most of the time is for 8-bit things, you know. For example, well, this is 16, but this is because it uses CL. But if it just changes the operand size, it's gonna be the same. Oh, by it's just gonna use the operand size is different. So, and then only A5 is gonna change a little bit there. Then we have REX the same, and this is the same. You know, we have just two instructions, well, two entries in the way we are doing it. For the shield left double, we just have two entries, one with A4 and one with A5, and then the other thing is it gets resolved when on compute mode, you know, on real time, let's say. Immediate 8, NA, and mod RAM. These are the two ways: MRC and MRI, MRI, MRREC, RM1. This is the CL. Okay. Good. So what about now? We have an effective thing there. There we go. So now we have the correct thing there, which it was missing, of course. So now we can copy all this and have it here. So the thing that we wrote, well, let me pass it as well. So we probably want to make it, I don't remember if we had a way to black copy it. Well, I can just say this. That was the only change. So there you go, we have the other things as well. That's good, that's good. And what else? What else we are missing here? So yeah, so now, I mean, just for finishing this up, let's try to, since we're on 64-bit mode, let's erase the 32-bit one, you know, because this is not encodable. So we have to do something special with this one. The other, oh, in this one. So these two instructions shouldn't be printed out, you know. They shouldn't be there. They are not possible to be encoded. If I go and say, for example, if I go here to the test asm and say, hey AD, please. I don't care, AD. Then this is like, hey, syntax error AD, what's going on? This is not possible. So this is pretty much the thing, you know. The assembler test us for that, or well, it checks that compile time. It's possible for the compiler to do that, because yeah. So we can just check it as well. The problem is that well, let's try. We can find a way to do that, you know. We just can say, well, on the CCP side, we just have to say something there, like, hey, we don't disassemble that stuff, or we just go past that instruction, which would be the case. Normally you wouldn't have to find that problems, because, well, or the instruction stream was done by the assembler and it was pretty much careful about it. But even the assembler can have an errors, you know. It's not like, oh, the assembler is perfect, or the compiler or whatever. So the compiler can just print bananas, you know, and we have to decide whether we go that route or not. So I mean, the thing that we could try to do, I'm sorry. Normally the first thing that we should do is, imagine that we are in 64-bit mode. We find out that there's a, you know, there's an opcode that we don't find on 64-bit mode, and we say, well, it's on 32-bit mode. Okay, so we put it on 32-bit mode. Now since, I don't know, I mean, you cannot have 64-bit and 32-bit code on the same code segment, isn't it? I think that's not possible. You can have different code segments with different operation modes,
I think that's possible. It was on on it was something. I don't know if you I saw it somewhere. I don't remember, but we have to find out that. So that would be the only case to find out something like that. So it's not like, oh, we're gonna get something. We have to match it with the mode that we have to find out. So we have to fetch. We have to match the instruction set with something useful. Which is the kind of thing. And the problem is that if we find that kind of if we find that case, that we find something that it's not compatible, uh, the problem is that if we just, let's say we just skip it one by, everything will go bananas because the ordering of the stuff is such a way that the encoding at least should, I don't know, but I mean we're making a lot of assumptions here, but um, if we assume that the instruction string has to be consecutive, that means that we shouldn't have we shouldn't even check for that. I mean, we should just go like wise and say, hey, we don't have to do that. We don't have to check for it. We don't have to make any of those check-ins, because making the spacing will by itself, doing that spacing will make each of the other instructions just wrong. Because we have to respect the ordering that he has, at least now, because in the way that we have it, we have to do it that way, because if not, everything is gonna go bananas. So we cannot have its spacings. We cannot move the pointer to the next byte and say, oh, this is the way we're gonna do it. That wouldn't be the case. That because pretty much then we lose it. We lose the instruction stream. So I think it's better if we just assert that we find another encodable instruction for now, and yeah. So if we find out that there's not an instruction, let's just assert it. Well, assert or log in it. Probably is we can right now we can assert, and later we can log it. It's somewhere. Like, hey, we have a fun. And yeah. So yeah, we can do that. We can say for now, since we have those two instructions, I could say here,
which of course is we're gonna we shouldn't assert it. Well, for now, let's just do that, I guess. Because if you remember, we do this whenever we end up the stream, so we pretty much we're not gonna advance at all. We're gonna get okay. So this is the reason why it's working right now. It's because it defaults to may not buy and just keeps moving on. So right now we're just on the thing that we don't want to do. Mm, it's kind of weird. Well, I don't know what exactly is the best thing to do here. So missing up the buffer. We can just break, I guess. And that's all she said. Of course, we want to do. Well, it's more likely to do. Yeah. So yeah, that's it. That's it. I just said to do. So we can just say like, well, this time we are just gonna say where is it? Over here. Whenever we get the table ID for that instruction and we get the result, the mnemonic one thing is like, okay, the table should not have the ID at all, or it's because there's a mix, isn't it? I mean, on the tables itself, we have mixes of valid 64, valid not valid 64. Some some of them are valid, some of them are not. So I mean, the simplest thing to do is just the entry having the data information. But and yeah, I mean, because it's something that is entry relative. Each instruction has its own. So normally, because of REX, we'll have that thing. Whenever we change to, let's say, 86, we will need to do something different. You know? Like REX is not possible. AAD is not possible. I can just say yeah, for now, let's say something like that. Probably we're gonna change that later, but I think this is gonna do it. This is just gonna say, well, we're not gonna anything. We're gonna break whenever we get to the bounds, you know. So we're not gonna print the whole stuff. Which probably it's okay because we can have two streams different, you know. We're not gonna have that kind of stuff. I have to find out if that's possible. If that's the case, we have to make something clever there. But I think we're gonna search that on the next stream. So for now, I'm just gonna say that, and we're gonna say, hey, what's gonna happen? So first of all, we're gonna have two that are compatible thing. Oh, and of course we have to set that. Okay, so we have to go to the init thing. Init and the instructions that we have on the disassembly H. Let's go to table. Oh, disassembly H. So where is it? Total entry count. Operation mode 64-bit, operation mode 32-bit, I have 32. Which, let's go at 32 bit. Why not? Why not? So let's copy this. Well, the add entry, we know that is valid on both, so that's okay. I'm gonna put it at the last thing. So here, this is the add. This is only 32, so let's put it that way. This is the bound. It's only 32 as well. This is the move, which is both, I guess. This is the problem. This is where I was like, well, we can keep it like this because it's valid on both. Just if, yeah, because, yeah, I mean, it's possible to do it. We just need the REX. So yeah, okay. So yeah, this is the shield, and this is gonna be shield. The shield is valid on both. The PLINR is, well, where is the other one? PLINR is valid on both as well. The VM resume, it's valid on both. The add entry is valid on both. The float is valid on both. The FUCAM is valid on both. The VAF is valid on both. And that's it. So the only one that is 64-bit is REX or RDX, okay. So let's compile that. And this is on the table. I don't know where you have it. Operational 62. I have 32. We have 32-bit, I guess. I can call this compatibility. And then we have there you go. So if that's the case, we go here to get and we can say So that's pretty much the case. So now, I mean, we just like do the simple stuff and just erase it. So if we get rex, we're gonna get the flag. That's possible. We just need to use rex present and it's gonna print it. If we're gonna go rex and do the full flags thing, well, yeah, I mean, it's gonna work. It's just gonna print both, I believe. So let's see what happens. So we're gonna go for the first one. Let's go and see what happens. It does not have any rex prefix, so which you're gonna get for the other one. We're gonna get the mnemonic. Let's see what happens here. You know, we got the result, and the result tells me that we have an operation mode of nothing. Are you serious? It's a move. Ah, did we indeed put it there? Oh yeah, the problem of all things. Yeah, my bad. My bad. Shift entry, move entry, bound entry, add entry, add entry. P-line entry, view resume entry, add entry. Fill entry, freecom entry, fab entry. That's all. It's a tree. It's a trio. There you go. Begin upper extraction. Then we print it out. Normal stuff happening. Do 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 do. Then if C by, this is gonna have the rex, and then we're gonna get the mnemonic. We got operation mode. There you go. There you go. So now this instruction, this is the important one, because this, my friends, it's this is the bound, isn't it? This is not encodable as 1. That means that it's gonna be 0. Return the result, and we say, hey, we just go out. Okay, that's good. That's good. Now we have a little bit sense of that instruction. It's not properly encodable. So probably what we are gonna do in the future is just gonna have something like this. I'm gonna move. Well, I can just start this instruction stream 32, instruction stream 64. So we can just test both of them in a simple way. And let's just pass the ones, I don't remember which were. the bounds, it has to be this one, and it has to be the fifth. There we go. So this string should be totally decodable, isn't it? So we compare them, and they say, well, 64. We can even say system state operation mode and system state operation mode 64-bit instruction state, if not instruction stream 32. There we go. Can do that. We have this. What? Why do we? Oh my god. Okay. And let me put this here. So yeah, that's better. This is 64. The well, I think it's better if I say this. Now let's see, buddy. Well, we have Alright, so let's see what happens now. This shouldn't be here. Let's go over there. We are on 89. That's correct. So this is gonna be the same. We should get the same thing, but we are just having a pure stream of 64. There you go. And this is math. There you go. A fab. There you go. Then we have a gum. There you go. Then we have float. There you go. And then we have VM resume. There you go. And we have the same instructions, but now we just have the instructions that are allowed in 64-bit mode, which, if we compare to this thing, it's gonna be, well, I can move this over here and this over here. So we have a move, EX EDX, REX RDX, EAX FFF0, OB, FN ST0 ST1, FUCAM ST1 ST0, FLD 0004, PM resume, PL line R XMM0, XMM1 08, shield blah blah blah, EAX 03, and EAX 000000. Okay, that's pretty much it. Which is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So yeah, so I'm gonna put here alright. Again. So yeah, I think that's all she said. We compile and we run this. And we have our stream back. Okay, I like that. I like that. So I think I'm gonna stop here. But yeah, please, if you have any questions, post them on Twitter or YouTube and I'll be there to answer. Please make your questions related to the thing we did today so I can answer them easily.
Please. Yep, I would say thank you very much, and I will see you all on the next stream. Take care.